Hi, welcome to my YouTube channel. This video I'm going through some idea about distributive law in our set and give you guys some idea about how to prove them. Distributive law means for all sets A, B, and C, then we have A union the intersection of B and C equals to A union B intersects A union C. The next one is conversely, if we want to find the intersection of A and B union C, it really indicates as the intersection of A and B, union the intersection of A and C. So I can give you guys some proof about first one and leave the next one as exercise. So first one, keep in mind if we want to find two sets are equal, then we need to find this set is a subset of this set. And conversely, this set is also a subset of this set. This is by definition about subsets. So we can prove the first side first. We need to prove this set is a subset of another set. So let's recall something about subsets. If this set is a subset of this set, which means every element of this set is also an element of this set. So now we can suppose X is the element of A union the intersection B and C. Then by definition of the union, we can get X is the element of A, or X is the element of B and C. So let's consider case 1. If X is the element of A. If X is the element of A, then we have X is the element of A union B. This is by definition of the union. For same reason, X is also an element of A union C. So these two guys is by definition of the union. Now, if X is an element of A union B, also an element of A union C, so what should we get? We can get the A is the element of A union B intersects A union C because X is also in this set, and also in this set, so we can find the X in both sets. So this is by definition of intersection. Now we can look at case 2. Case 2 is X is the element of the intersection of B and C. So by definition of the intersections, we can get X is the element of B and X is the element of C. So if X, so from this one, we also have two cases here. If X is the element of B, then X is the element of A union B. This is by definition of the union. And also, X is the element of C. Then we have X is the element of A union C. So these two guys is also by definition of the union. So from these two, we have X is the element of A union B intersects A union C. So either two cases, it follows that A union B and C is a subset of A union B intersects A union C. Let's prove another side here. Well, if we want to prove the intersection of A union B and A union C is a subset of the A union the intersection of B and C, then it's quite straightforward. We can still suppose X is the element of the intersection of A union B and A union C. So, which means X is the element in both sets. Now, from the definition of the intersection, we have X is the element of A union B, and X is the element of A union C. Now, let's still consider two cases here. The case one is if X is the element of A. So if X is the element of A, then from the definition of the union, we can immediately to get the conclusions here. Then X is the element of A union the intersection of B and C. Now, the case 2 is if X is not an element of A. So if X is not an element of A, but we have X is the element of A union B. So if since X is the element of A union B, but X is not an element of A, then X must be an element of B, because X is in at least one of A or B. So for some reason, since X is the element of A union C, but X is not an element of A, so X must be an element of C. Now for A and B, we have X is the element of B and C, the intersection of B and C. This is from the definition of the intersection, which means X is in both sets B and C. So then it follows the union that X is the element of A union the intersection of B and C. So in both cases, by the definition of the subset, we have the intersection of A union B and A union C is a subset of A union the intersection of B and C. Now, from the both side proof subset relations has been proved, we can give the conclusions here. A union the intersection of B and C equals to the intersection of A union B and A union C. Thanks for watching. If you have any questions or any other topic you want to listen, or you just want to give me some comments, please leave your comments below. The next video I will provide some information about De Morgan law and how to prove them.